Hello, my name is Ryan McMillan. Today I'm here to talk about SSH, and we're going to have a technical discussion and also look at some hardening recommendations for SSH. This is for ISA 4220 Spring 2020. So let's go ahead and dive in by taking a look at the technical side of SSH. So, what exactly is SSH? SSH is a network protocol that provides a secure way for administrators or anyone else to access a remote computer. SSH stands for Secure Socket Shell, and by default, it uses TCP port 22. It functions basically by providing a cryptographically secure connection between two separate parties known as the SSH client and the SSH server. And it does this communication by creating an connection in three separate stages. So the first step in establishing and creating an SSH session is verification of the server. And what this is basically when the client wants to initiate an SSH connection with the server will be listening on port 22 or whatever port you have SSH running on. In this case, we're using 22. And then the server identity is needed to be or it needs to be verified. This verification happens it happens in two possible ways. It depends on whether or not this is the first time the client is actually accessing the server. So if it's the first time, the client is going to be asked to authenticate the server by verifying the public key of the server. And to find the public key of the server, this can be found using SSH keyscan command. And once it's verified, the server is going to be added into the client's known hosts file in its SSH directory. And this known host file is what contains all the information about verified servers that the client has access to. And of course, if this isn't the first time that a connection has been made from the client to the server, then the client will just look through its known host file for previously recorded identities of servers and see if the server that it's connecting to is located in that file. And once it finds it, then that's how it gets verification. The next step in generating an SSH connection or creating an SSH connection is generation of the session key. This is done after the server has been verified, and it's done by both parties negotiating a session key, and they use a version of what's called the Diffie-Hellman algorithm to generate the key. Now, the Diffie-Hellman key exchange is just basically a secure method of exchanging cryptographic keys over public channels, and it's a one of the earliest examples of public key exchange used in cryptography. One benefit of it is that the algorithm is made in such a way that both the client and the server contribute equally in generating the session key. And the session key or the generated session key is shared symmetrically, meaning it's a symmetric key, which then in turn means that it is used for both encryption and decryption. After this is done, it leads us to the final stage, which is authentication of the client. So there's a lot more steps that go into authentication in the final stage. One of the first things that should be noted is that authentication will be done using an SSH key pair. And basically, what this means is that it's done using a pair of keys each used for separate purposes. You have the public key, for instance, and the public key is what's actually going to be used to encrypt the data and can pretty much be shared with anyone. And the other key generated is the private key, and this is what's going to be used to decrypt the data. And of course, you don't want to share that key with anyone. So let's look at how authentication of the client continues to happen. So the client sends an ID for the key pair that it wants to use for authentication with the server. This ID is then checked by the server in a file known as the authorized keys file, and it looks to see whether or not a public key with the same ID that was sent from the client is located within the authorized keys file. If a matching ID is found, the server will then it'll generate a random number and it'll use the public key to encrypt that number and it'll send the message back to the client, the encrypted number. Once the client receives that number, if it has the correct private key in its possession, it can use that private key to then decrypt the message and obtain the random number that was sent to it by the server. After that, the client will take that random number and it'll combine it with the shared session key to calculate what's known as the MD5 hash of the value. And this MD5 hash value is then once again sent back to the server. The server then in return takes that session key and the original number that it sent to the client and it calculates the MD5 value as well. So basically, both the client and the server are performing the same action in this case, which is the combination of the key and the number to generate an MD5. And if the two values then match, then the client will be authenticated and it's proven that the client was in possession of the correct private key. Once that's complete, the client's authenticated, the server's authenticated, and so encrypted communication can begin between the two. So now that we have discussed the technical side of SSH, we can go ahead and look at some of the hardening procedures that you can use to secure it. Um, One of the first things we will talk about on this slide is the use of TCP wrappers. And what TCP wrappers works using two files. Both are located in the etc directory, located under host.allow and host.deny. The first thing you're going to want to do is deny all connections that are from unknown hosts. This can be done by doing the nano command, which is basically just a text editor. So you do nano-w etc host deny. And then inside this file, you'll want to add the line all :all. And basically what this does is it'll block all unknown connections using SSH. And if you want to only allow, for instance, your own IP or our own IP, we can use the same nano command and go into the host.allow file using nano-w/etc/host.allow. And then in that file, you'll add the line SSHD space : and then whatever your IP address is that you want to allow for SSH connections. So basically what this does is prohibits any attempt at an SSH connection unless it's only originating from the specified IP address in the host.allow file. So the next hardening recommendation that can be done is actually quite simple. And this is basically just setting a idle timeout interval. And that's just a complicated way of saying that it is preventing SSH sessions from staying active and available for long periods of time, and it terminates them based on a given value. So in order to do this, you'll need to change the client alive interval value, and this value is located in the nano dash w slash etc slash ssh slash shd underscore config file. And once you're in there, you'll see a value called client alive interval. And what you'll want to set that to is basically however long you want your connections to remain open. Um, so, for instance, if you wanted it to be 5 minutes, you would set it to 300 seconds. So you'd just set it to client alive interval equals 300. By doing this, you're able to prevent SSH connections from staying open when no one is using them, and the SSH sessions are just automatically logged out at the given time interval. This last slide, we'll just go ahead and list about 3 or 4 hardening tips you can do real quick. The first thing, as you can see, is you want to disable X11 forwarding if possible. Um, this is because it's possible to be hacked using X11 forwarded traffic. So if X11 traffic isn't needed, it's recommended to disable it by setting your X11 forwarding value to no. The next thing we can recommend is disabling rhost. And we want to disable this because rhost is using a weak method to authenticate systems. It basically is trusting systems simply based on their IP addresses. And so you want to go ahead and disable this by setting the ignore rhosts value to yes. Another value we'll want to change is the max authentication attempts. One of the common methods of gaining access into an account, gaining unauthorized access, I should say, is through brute force attacks. And this is basically where the attacker keeps on repeatedly guessing the password one after another, usually using some sort of script or software in order to gain access. So by setting the max authentication attempts, you're limiting how many tries they can get before they are locked out. So this can be done using the max auth tries value, and you can just set that to whatever number of attempts you want to be able to allow. Building on top of this, it's also recommended to force public key authentication instead of allowing for password authentication. And once again, this is just to minimize the possibility of a brute force attack. Um, by forcing the connections to only use to only use public key authentication. So this can be done by setting two values, by changing two separate values. You want to take the pub key authentication value and set it to yes, and then you want to take the password authentication value and set that to no. And by doing this, once again, you're just disabling password authentication for SSH and enforcing the SSH key, public key authentication. So in conclusion, we looked at SSH and we took a quick technical discussion and discussed how SSH is just known as Secure Socket Shell, and at its core, how it provides a secure encrypted connection between a client and a server using using a public key and a private key. We also discussed how it uses port 22 over TCP, and basically just the steps it goes through to authenticate clients and servers. We also discussed some of the hardening recommendations we can take to make it more secure. This was through either using TCP wrappers to make it so that only given IP addresses can connect through SSH, by setting idle timeout intervals so you don't have open connections um, maintaining themselves between the client and the server. Uh, then there's also disabling X11 and rhost. And then, of course, to prevent brute force attacks, we want to limit authentication attempts to whatever value works best for you, basically. But it's recommended to keep that kind of low so that people can't brute force into your client or server. And then it's also important to force key authentication by disabling password authentication because, once again, passwords are going to be a lot easier to brute force than a public key. So, yeah, that about sums it up. And thank you.